everyone, welcome to Code with Laya. Today I am going to explain you the topic queues. Okay, so what is meant by queue? Queue is a linear data structure, right? It follows first in first out principle. Follows first in first out principle. Okay, and the queue has two ends. First end is called as front. We have already seen the introduction to queue during the data structures types, right? And now we'll go into this topic in detail. So this is called front end and this is called as rear end. Okay, so you insert elements from the rear end and you delete elements from the front end. Okay, so what is the real-time application for queue? Say for example, you're at a movie ticket. So you're at a movie theater. So you went for the ticket. This is the queue. 5 members stood in the queue. Right? So you are the first person. Who will be served first? Since you are the first person, you will be served first and you will come out of the line first. Right? Next, who will be served? The second person. After this person will be served and come first. Right, this is how a queue works. Insertion is done from the back end. Insertion is done from the back end and deletion is done from the front end. Okay, so now let's see how queue works. So when there are no elements in the queue, then front equals to rear equals to -1. Since there are no elements and queue is empty, then you will represent the status of queue as front equals to rear equals to -1. Okay. Now, if you try to insert elements, okay, or delete elements, these operations are called as Enqueue and Dequeue operations. Okay. So, we generally do what operations we generally do? Insertion and deletion, right? So, in the stack concept, you call insertion and deletion as push and pop. Okay. Now here in the queue concepts, you will call the terminology as Enqueue and Dequeue. Enqueue means insert, Dequeue means delete. So there are two operations you can perform mainly on the queues. First one is Enqueue and second one is Dequeue. Okay. Each time when you try to insert elements, rear value is being incremented. Okay. And each time you try to delete elements or dequeue elements, front value is being incremented. Okay. So when you try to enqueue elements, rear value will be incremented. And when you try to dequeue elements, front value will be incremented. Okay. Now I'll show you how to insert elements into the queue. So first one is Enqueue. Okay. Enqueue, some first thing is 10. So since I am implementing queue using arrays, okay, so I should follow all the rules of arrays also. Okay. Now front equals to rear equals to -1. Each time when I try to insert elements or enqueue elements, my rear value should be incremented. Okay. So what is my rear right now? -1. So it becomes rear equals to -1 plus 1. That is 0. Okay. Now I will add my 10 at 0th position. Now see. If you go like this, which element is being visible? 10. This is rear. Okay. Okay. This is rear right now. Now this way you're going. What is the element visible? 10. Then front is also becoming 0 now. So when the queue is empty and you try to add one element, first element, enqueue, first element, then front also becomes 0. Okay. Rear obviously increases, but when the queue is empty and you try to enqueue elements, that's the first element. So you can directly initialize front equals to 0. Right? Now what is my front here? Front and rear are pointing to, this is my front, this is my rear. So when I added this front equals to 0, rear equals to 0. From next time when you try to NQ elements, okay, you can directly increment rear. You need not touch the front, okay. So now I want to add 20. So now front equals to 0 as it is. The rear will be incremented. Rear equals to, it was before 0 plus 1 equals to 1. So 20 will be added at this position. Now rear is shifted here. Here rear is. Okay, my front is not changed. Okay. Next one. I tried to add 15. You don't have any rule that you should add elements in the sorted order or unsorted order. You can give the input in any order. So I've added 15. What is my rear right now? Rear is pointing to 1. So rear equals to 1 plus 1. So next 15 element will be added at second position. Okay. Again rear is shifted here. So now rear equals to 2. Okay. Again. Now I try to add 64. Okay. What is the rear right now? 2. So rear equals to 2 plus 1. Each time I try to NQ, I will increment my rear by 1. Rear equals to 3. Now 64 is added at third position. Right? Again I try to add 72. Rear equals to, already rear equals to n minus 1. Right? So my last element is filled with 64. My queue is already full. So if the bucket is already full, can you add elements into that again? No, you cannot add elements. Right? So now when the condition is already rear equals to n minus 1 and you try to NQ, then a condition arises, queue overflow. Okay. When the queue is already full, that is rear equals to n minus 1. What is n minus 1? N equals to number of elements 4. Okay. What is 4 minus 1? 3. So rear equals to 3. That means the last location is already filled. So you cannot add elements into the queue. Okay. Then the condition arises, queue overflow. Right? So now we'll see how to dequeue elements from the queue. Okay. So when I added this, I forgot to change this. Rear is here. Okay. Now we'll see how to dequeue elements from this queue. I deleted my, my front was before front equals to 0. So each time I dequeue my elements, front will be incremented. So front plus plus. Okay. Front equals to 0 plus 1. 1. Right. When you try to delete this element, this front points to its next element. So this element got deleted. Okay. So my front is pointing to my first indexed element. Right. Now I try to again dequeue one more element. So front equals to, again increment. Front was 1 and I'll add 1, becomes 2. So after deletion of this element, front is pointing to 2. Right? Then again I try to add one more, dequeue one more element. Front equals to 2 plus 1. Then what is my front? 3. So after deleting this element, front equals to rear equals to 64. This means when the front and rear are pointing to the same element, okay, it means there is only one element existing in the entire queue. Right? So again I try to delete an element. When it happens, when front equals to rear equals to same element, that is 3, then you try to dequeue. Okay. Now my queue, my front and rear values will become automatically -1. my friend, the values are automatically initialized to -1. That means the queue is empty, right? Okay. Now, after deleting this element, my front equals to rear equals to, they are -1. Now, if you try to dequeue, queue is already empty. Front equals to rear equals to -1. Now, if we try to dequeue elements, there is a condition arising called queue underflow. Okay, this is what happens when you try to delete elements from an empty queue. That is called queue underflow. You cannot delete elements since there are no elements in the queue. Okay, so this is how you enqueue and dequeue elements into the queue. Suppose you have deleted first two elements of a queue. Some first two elements are deleted. Okay, my front equals to my front equals to 2 and rear equals to 3. This is my front and this is my rear. Okay, now if I try to insert elements, will that be possible? I have two empty spaces, right? It should be possible to store my new elements in those, right? To use the memory efficiently. But I can only add elements at the rear end. I cannot add elements at the front end. Even after these two spaces are empty also, you don't have this availability of adding elements at front position directly. So this is the main disadvantage of queues. In case if the front spaces are free and the rear is already filled, the condition only checks for rear equals to n-1. But it won't check front equals to some, 2 or something. It won't check like that. It will only check rear equals to n-1 for insertion. That means enqueue operation. Okay. Now, this is the problem with the queue. So, we have moved to the concept circular queue to overcome this problem. Okay.